This video walks through all the new and enhanced features that have been added to version 9. So let's take a look at all of the new features and enhancements to drawing in version 9. To begin, let's create a new file. Now the first thing that you'll notice in the job setup form is that we have two job types that we can choose from, a single-sided job and a double-sided job. So a single-sided job is what you're already used to, but now we have the ability to create a double-sided job where we can create double-sided projects in the same session. So this avoids the need for us to create two separate files to create a two-sided part as we used to in previous versions to this 9 release. And we'll run through a full two-sided project later on in this video to demonstrate this powerful new addition. So let's just go ahead and press OK. So the first thing that we'll look at is the interface. So you'll notice that we've introduced a new toolbar above the view window here, which allows access to some of the more common tools that we use. So we'll start by looking at the Layer Manager. So the Layer Manager has been moved from the Drawing tab and is now a part of the View toolbar, so we always have access to our layers regardless of what tabs we're currently working in. So here we have various snap options that we can toggle between, and we'll come back to this shortly. Next section focuses on the pan and zoom options that have been moved from the Design tab to the View toolbar, again for easier access when we aren't in the relevant tabs where pan and zoom previously occupied. Next section we look at the toggle toolpath drawing visibility and the toggle between wireframe and solid view. So this has been moved from the toolpath tab to permanently live at the top here. So again allowing easier and constant access to these options. And then we have the tile windows options at the top here also. So you can tile horizontally, tile vertically. Now when we're in a two-sided environment, you'll also have access to a further few options within the View toolbar where you can flip between the top and the bottom side, and we also have a button that allows us to view the project in a multi-sided environment to help visualize the two-sided part, and we'll look at those options in the two-sided example later on. You'll notice that the Switch to Toolpaths tab now resides at the top of the Design tab, allowing us access to switch between the two regardless of what tab we're currently working with. And the same applies for the Toolpath tab, where we have access to switch back to the Design tab regardless of which toolpath tool we're currently working in. So let's go back to the snap options here. So we've got 3 toggle buttons, one to switch on geometry snapping, which we're already familiar with the idea of geometry snapping. Then we have a toggle button to turn on smart snapping, which is a brand new feature that we'll look at in a second. And then we have a toggle button to display the snap grid. One of the major improvements that have been added to version 9 is the way that we draw in the software. With the introduction of Smart Snapping, drawing has never been easier. So what is Smart Snapping? So Smart Snapping allows us to snap to lines and extensions that don't actually exist as real geometry, which reduces the need for us to create construction geometry, and it helps us to create and align vectors or nodes. So let's first take a look at the snap options. We'll go to Edit, into the snap options form. So we have 2 new options in the snapping options form. We have snapping radius and we have smart snapping. So let's first take a look at the snapping radius. So the snapping radius, we now have the ability to choose your own snap radius, and this is how close that you have to get to something in order for you to snap to it. Okay, so if I just select the slider and drag that along, you can see that with every increment I have a circle displayed to me, and that is the actual snap radius. So anything within the circle we're able to actually snap to. Okay, so the default setting is at 10 pixels. And then we have the smart snapping options. And so with smart snapping enabled, you have the ability to snap to all sorts of lines and extensions. So you can snap and align things to the bounds of an object. We can snap to horizontal and vertical lines, tangents, lines that are perpendicular to tangents, span geometry, and angles. So let's have a look at an example of how we can utilise the powerful Smart Snapping feature. So we can see that we have everything enabled here. So let's go ahead and press OK. So in the Layer Manager, I'm just going to use that drop down, switch off Layer 1, switch on Layer 2, make that the active layer. You can see I have a set of shapes here that we're going to use to help demonstrate the powerful Smart Snapping options. So we're going to demonstrate the Smart Snapping using the Polyline tool, and this works with any of the Create Shape tools along with the Draw Arc and Draw Curve tool. So let's go into the Polyline tool. So let's bring the cursor into the job. Now at the moment we are currently not seeing any form of lines or extensions that I spoke about earlier, and that's because I've not yet clicked to create the actual polyline and I haven't woken up an object for me to align to. So what do I mean by waking up an object? So in order for us to start to draw where we align our drawing to an existing object, we need to wake it up. So to wake up an object, we simply run our cursor over the object that we want to wake up, and then will be displayed with various lines and extensions based on the object that we woke up. So let's have a look at the shape in the lower right hand corner. So I'm just going to run my cursor over that to wake it up, and then I'm going to move the cursor away, and I'm just going to randomly move that around, and you'll see now that we're displayed with a blue line running vertically through the center of the object. So when you see a blue line, that's the software's way of telling you you've found an object bound. In this case, we've found the center vertical line for the object that we've woken up. Again, if I move my cursor, you'll see we've found the right object bound for the object that we've woken up. If I go up, we've found the bottom object bound, the center horizontal line for the object there, and we've found the top of the object, and again we've found the right hand side, the center, and the left hand side. And so having access to all of these lines just makes it easier for me to accurately draw new shapes that are aligned to other objects. For example, you can see that I'm still aligned to the top bounds of the shape in the right hand corner, so I can begin to create a new shape. Now when you create a shape, you can see here I'm presented with a vertical line. This just makes it really easy for me to create straight lines. And I can bring that down. You'll notice that I'm still picking up other points from the objects that we originally woken up. Okay, so I want to align that to the bottom of the shape, so I'm going to click here, and then I'm going to come across. You'll see now I've got a horizontal line. Again, really nice way for me to keep my cursor straight so I can create nice straight lines. I'm going to click that in place and go up, and so it's found the center object bounds for both shapes now. Okay, so it's found this one. It is actually this one that it's woken up, and I can tell that because of this dot here. And then I'm just going to go up, I'm going to align that to the top object bounds of the shape that I'm currently drawing. I'm going to click that in place. I can also do angled lines, so you can see I can follow along those angled extensions, making it a lot easier for me to create accurate geometry there. So I'm just going to click that in place at the center, so it's found the center object bounds for the object that I'm currently drawing, which is handy. and then we'll just bring that down over here to join that up. We also have the ability to wake up multiple objects that we may want to align to. Let's just close out there. I'm going to take this new shape, I'm just going to delete it. I'm going to go back into the polyline tool. So I'm going to wake this shape up here, I'm going to wake this circle up here. And if I follow along the right object bounds of the circle, I'd like to create a new shape that is aligned to the top of the right hand shape in the lower right hand corner. You'll see that I'm able to snap to that point to begin a new shape. So there's lots of scope here in order for you to draw up vectors that are aligned to various geometry that you have in your job. So we've looked at the object bounds, we've looked at horizontal and vertical lines and angled lines. Now Smart Cursor can also pick up tangent lines. So let's wake up this circle here, and if I just move my mouse along, you can see that the software has found a tangent line, and I can click and then I can just follow along that line, click that in place. And the software can also pick up lines that are perpendicular to tangents from nodes or midpoints. And so you can see that we're displayed with that right angle there. And that's the software's way of telling us that it's found a line that is perpendicular to that tangent. So let's just right click there. We're going to take that vector, we're going to delete that. We'll go back into the polyline tool. Now Smart Snapping can also find connecting lines by waking up two different points. For example, if you cast your eyes over to the top right hand corner, you'll see that we have a square with a smaller square inside of that square. Now if I wanted to create another square that was between the two squares, all I'd have to do is simply come over, wake this point up here, wake this point up here. Then as I come back, you'll see I'm now displayed an olive green line, and you'll see my cursor's change. It's telling us that we have now found a connecting line. If I follow that along, you'll see I now have a snap point. That's telling me that this is the dead center of the 2 points that you just woken up. And I can click that to begin creating my shape. So again, wake this point up, follow that back, and I've found the connecting line. Over to this side, wake this point up, and I found the center there, this one and this one, found the center there, and then I can click to finish that drawing. And the same applies to open vectors. For example, wake this point up, bring that along, and you can see that I can find the center of that line, or I could just connect anywhere between the two there, like so. And so Smart Snapping is a very powerful feature for us to create accurately aligned vectors very easily without the need to create construction geometry like you saw in this example. Now, not only can we draw with the help of the snap options, but we can also align objects to the various points. So let's have a look at how we do that. So let's just take this vector and to delete it, take that one, delete it. We'll take that center one that we just created, and we'll also delete that one. So let's just take this square, put it into transform mode, and then we're just going to take that, I'm going to wake this circle up, wake this point up here, and you'll see that I'm presented with various lines. At the moment I'm currently aligning the square to the left side of the circle and the bottom of the shape that we have in the lower right hand corner, and I can put that in position, and that's now aligned. So there's lots of scope here to align objects to other objects that you have in your job without using the alignment tools. So not only can we make use of the Smart Snapping when drawing shapes and aligning shapes, but we can also make use of the Smart Snapping when we're in Node Edit mode. For example, with this square selected, let's press N on the keyboard. I'm just going to press C to cut this point here, then I'm going to take that node, and you'll see that I'm able to follow along that vertical extension there. I'm able to snap to various points with other objects that we may have in our job. So it just makes life a lot easier being able to snap to all of the various points from various objects when in node edit mode. And so the addition of smart snapping makes drawing and aligning vectors so much easier to do than in previous versions. So now we're going to look at a new feature added to version 9 that helps us to draw shapes without having to type in values into the create shape forms. And this is what we call transform shortcuts. So let's just go to our layer manager. We're going to switch off layer 2, switch on layer 1. We're going to start by looking at the draw circle tool. So in previous versions, to draw a circle, we'd simply either enter in the precise center point, followed by a radius or a diameter, or freehand draw the circle in place. With the addition of transform shortcuts, I'm able to simply click to create a circle, okay, and I can draw out the circle. And if I wanted to give it a precise diameter or a radius, I could use the transform shortcut keys. So whilst my left mouse key is held down, if I wanted to give this circle a diameter of 2 inches, I'd simply type in 2 as highlighted at the bottom there, followed by the letter D, and then that will create a circle that has a diameter of 2 inches. You can do the same for radius, so I'd simply click to create the shape, drag the shape out, and whilst my mouse key is still held down, I'm going to type in 1R, and then that will create a circle that has a radius of 1 inch. So let's just close out the circle there. Let's take a look at drawing a rectangle. So to draw a rectangle, we simply begin drawing the rectangle with our cursor, and then we type in values that apply to the width and then to the height. So the first value is the width. For example, I want to have a width of 1, so you'll see highlighted at the bottom, I'm going to type in the value of 1 for the width, comma, 1 for the height, and I'm going to press return, and that will create a square that is 1 by 1. So let's have a look at another example. Okay, so I'm going to start to draw the rectangle. This time I'm going to put in a width of 3, followed by the comma, and I'm going to give that a height of 2, followed by the return key, and that will create a rectangle as a width of 3 and a height of 2. Now, not only can I use the transform shortcuts to create accurately sized shapes, but I can also move, rotate and scale objects without having to open up any forms. So let's take a look. So we'll just close out there. I'm going to take this rectangle, just going to delete it. And so first let's have a look at how we can move an object. So I'm going to select this square, select it again to put it into transform mode. Now the way that we move objects with the transform shortcuts is we select it and then we move it in the direction that we'd like to move the object to. For example, I'd like to move this up the y-axis, and I simply press 1 followed by the enter key, and it will move that up by 1 inch. I could bring that back down again by selecting it, moving that down and pressing 1 followed by enter, and it will move that down by 1 inch. Not only can I move objects relative to its current position, but we can move them to absolute positions in our job. For example, I'm going to take the center point here, with that selected. I'm going to type in the exact location that I want to position this into. So I'm going to type in 0x 0y, and it will move that center point to x0, y0. Now if I wanted the lower left hand corner of that square to be at x0, y0, I'd simply take that corner there, select it, and then I'd press 0x, 0y, and it will move the lower left hand corner to the position that I asked it to. And so using the transform shortcut keys to move objects is much quicker than going into the actual move selected objects form. So let's just take that square, I'm just going to move that over. I mentioned that we can also use the transform shortcut keys to rotate an object, so I'm going to take that handle and I'm just going to start rotating it. I'm just going to type in 45, you can see that at the bottom, followed by enter, and it will rotate that for me by 45 degrees. So again, much quicker to do it this way than to have to go into the rotate objects form to then put in a number to rotate the object by. So let's just undo that. We can also look at sizing the part, so I could take that, pull on one of the handles there and simply type in a new size. For example, let's go with 0.5, 0.5 and then press enter, and then it will change the size of my shape to a width of 0.5 and a height of 0.5. We could also look at scaling an object in multiples of its original size. So for example, with this square 0.5 by 0.5, if I wanted to make that 3 times bigger, I could simply pull on the handle in the direction that I'd like to scale this up by, and then type in a number, for example 3, followed by the letter S for scale, and then that will scale that up 3 times its original size. So there's lots of shortcuts there to make for a quicker workflow without having to go into various forms. And there are many different transform shortcuts for the different shape creation tools, and all of the shortcut combinations can be found in the help guide and are used throughout many of the tutorial videos. So now let's have a look at a new tool that's been added into version 9, and that is the Vector Validator, and that can be found in the Edit Objects section, and it's this icon here. So this tool will enable us to find issues with vectors that are typically imported into the session that may get in the way of toolpath creation, where it looks for overlapping and intersecting vectors and zero length spans. So let's have a look at importing a vector file. So I'll go to File, Import, Import Vectors. I've got a file here. I'm going to open that. I'm just going to go to the Layer Manager, switch off Layer 1, and we'll take a look at what we've got here. So here I have a set of vectors, and because this was created in third-party software, I'd benefit from having the Vector Validator glance over those vectors for potential issues that may arise when I come to create any toolpaths. So let's go into the Vector Validator. And so as I said, this tool will help us find potential problems. It's going to look for 3 key areas. It will look for zero length spans. So span has a start and end point, and a zero length span is where the start and end point are on top of each other, meaning there is zero length between the start and the end point. We also have overlaps, so this is where we have vectors overlapping other vectors, and we have intersections. This is where vectors can intersect each other or other vectors. And so we have the ability to search for these problematic areas, and if the Vector Validator finds any of these issues, it will highlight the problem area to us by using one of these indicators. So we've got a 0 and a blue square for zero length spans, a pink square and an equals symbol for overlaps, yellow square and a plus symbol for intersections. To search the entire part, you simply use the button to search all. And so you can see we've got lots of symbols in our job. And if we take a look in the Vector Validator form, we can see we currently have 12 zero length spans, 48 areas are overlapping, and we have 99 intersections. Okay, so let's just take a look at the zero length spans. So we can see we've got 12 of those, and if we just take a look in our job, I can see they're all relevant to the actual Snow White text. Now we have the option to fix those zero length spans, so I could just click on that and that will eliminate the zero length spans there and fix them for me. And so in the key now you can see we have 0 zero length spans. If we take a look at this area here, I can see we've got quite a lot going on. We can see we just have overlaps and intersections there. So that gives me an inkling that we might have an overlapping vector. So let's just use this option here to zoom to fit. We'll close out of the form there. If I select that vector, I can clearly see that it is a vector overlapping. So if I can take that, put it into transform mode and move that out the way, we can see that it was one circle on top of another. So I can take that circle and I can delete it, and here I can see that we should just have one circle there. So let's just zoom to fit, and we'll go back into the vector validator, search all. We can see that we have no issues here for that circle, and that's because we had that overlap. At the top here I can see we have an intersection here and an intersection there. So let's just close out to take a look at what this is. So on the face of things, it looks as though we have one rectangle. Now if I click on that shape, we can see that the rectangle is actually made up of two vectors, and it's not actually a closed shape. So I'm going to take those, and then we're going to look at joining them. So we'll join that, close that down, back into the vector validator, search all, and that's now eliminated that problem for me. So now I have 0 zero-length spans, 0 overlaps, and just one intersection. So let's take a look at that intersection. Okay, so I can see here we do have a problem with this vector, so let's just close out there. We'll go into node edit mode, and we could just look at fixing that, or I could just simply look at deleting this node here, press F to fit that to the screen, and that should have cleared that up. So when I go back into the vector validator to search all, we have no problems there. So a very useful tool to just scan over any vectors that you import, and it will search for these problematic areas. For more information on the vector validator and to see it in action, you can take a look at the Working with Imported Vectors guide tutorial. So now let's take a look at some of the enhancements we've made to drawing in the software. Into our Layers tab, just going to switch off these layers. I'm going to go back to layer 1 in this case, close out of the vector validator form. So we've made improvements to the Dimensions tool, so let's take a look. Go into the Dimensions tool. Okay, so here let's just go to the length option, and we'll just look at creating a basic dimension here. We're going to snap to the sides. You'll notice here that I'm able to position the text box wherever I want within my job. Okay, so I can just click that in place, and you'll see that it's created that dimension. And you'll notice that the dimension is grey. So with 9 we've changed the colour of the dimensions layer so it's more subtle. Okay, with that in place, I can edit this dimension by holding down Shift, and I can select it, or I could maybe look at increasing the height there. I could change the font if I wanted to. And then I could also look at using custom text. So rather than it display the actual dimension here, I could use this check option here, where I could input any text that I wanted here. For example, I could just type in width and whatever I wanted to put in there. To revert back, I can simply uncheck that, and it will display me with the actual dimension value there. If we go to arc dimensions, it will recognise when a circle is selected, and I can place the dimension anywhere around the circle. So you can see it's picked up that arc here, so I could click that, and then I could position the box wherever I wanted. For example, let's put that there, and you'll see it's telling me that has a radius of 1. I also have the option to show diameter. For example, let's go over to this one. So again, it's highlighting that arc for me, and then I could just input that, and it tells me that I have a diameter of 2. So some nice new improvements there, and you'll see this tool being used in some of the tutorials. Another enhancement we've made, which you saw briefly here, is the ability to edit shapes whilst in the relevant shapes form. So you saw that I held down Shift while selecting a dimension in order for us to edit that. Let's have a look at some of the other shapes that enable us to edit existing shapes. So we'll close that down. I'm going to go to the Layers tab to switch off the Dimensions layer, and then we're going to go into the circle form. So as we're in the Draw Circle tool, all I'm able to do at the moment is actually draw a circle. If I wanted to edit an existing circle that we currently have in our job, which I can see we've got 2 there, all I need to do is edit the shape by holding Shift while selecting. So I could hold down Shift, select it, and you'll see I'm now able to alter this shape. So I'll make the diameter of that 1 inch, and that will change that for me. And this holding down Shift while editing a shape applies to all of the various create shape tools that we have. Another little gem that we've added to our enhancement list is the ability to create tangents to and from a circle and creating tangents between 2 circles, and that's where we use the polyline tool. So we're going to go into the polyline tool. So to create a tangent line to a circle, I simply click, come over to the circle, press T, and then that will create that tangent line for me. So you see that again, so let's just go over, hover over the circle, press T, and then that will create that for me. Okay, going between 2 circles, simply click on the one circle, click to another circle, then press T, and then it will create the tangent line between the 2 circles there. So very handy tool for us to be able to accurately create these lines. So let's just switch off layer 1, and we're just going to switch on the layers where we imported those vectors earlier. And another enhancement that we've added is the ability to export the vectors as a PDF file. So go to File, Export, and you'll see that PDF has now been added to the list there. And so here we have various options that we can define. So you could choose a sheet if you had more than one sheet. You could choose your layers, so all visible layers, or you could be specific and select the particular layers you wanted to export out there. And then select the vectors, so export all or the selected vectors only. So we'll just go with all visible layers, export all, press save, give that a name, and then you can simply save that. And so this means that we can open up the PDF document. So here it is. I could double click on that and we can see our part as a PDF. And here we could look to print the file to scale if we wanted to, and it's just a nicer format for me to send designs over to my clients. So the first thing that you'll notice is that we have an additional icon in the modelling tools here, and this is an icon that allows us to create a zero plane. Now the ability to create a zero plane isn't new. In previous versions, to create a zero plane we access that using the model drop down menu. For ease of use we just introduce an icon as part of the model creation tools. Now a new feature that we've added into 3D Assembly is what we call the mirror mode. And this allows you to define a component level so that it mirrors all of its components in a certain way based on the mirror type that you've selected. And this allows us to effortlessly create interesting symmetrical layouts. So here I have a piece of clip art within my job, and so to access mirror mode we access it from the level itself. So let's go over to level 1, right click, and you'll see under combine mode we now have the new option here to apply a mirror mode. Okay, at the moment we can see that no mirroring is currently checked. That's why nothing is currently being mirrored over in the 3D view. Now mirror mode allows us to place in virtual mirrors within the centre of your job vertically, horizontally, or both at the same time. And according to what mirror mode you are using, the software will mirror any components that you have in the area of the job that you are mirroring. So the top 4 options here will show one mirror position, and then the bottom 4 options will show 2 mirror positions where we mirror by quadrant. So let's take a look at this option here to mirror left to right. And so what it does is it will take any components that the software can see on the left hand side and it will mirror them over to the right hand side. So you'll notice how we have a mirrored version of this component here in the 3D view on the right hand side. However, we still only have one component in the component tree and we have one component in the 2D view. And this is because the mirror property is part of the level itself. So it's similar to the combine mode, and so we only see the result of the mirror mode and the combine mode in the 3D view. Also notice that the icon has changed here. We've got a red line running through the actual combine mode of the level there. That's just indicating to us that we are currently in a mirror mode where the mirror has been placed vertically in the center of our part. And so when I take this component, if I move it, you'll see that everything is being mirrored on the right hand side, like so. I can rotate it, I can stretch it, and you'll see that it's being mirrored. Anything that comes past the mirror line will not be mirrored. It only accounts for anything that is currently on the left hand side, because that's the mirror mode that we are currently using, where we're mirroring left to right. Then we have various other options. We've got right to left, so it will take everything on the right hand side this time and it will mirror them over to the left. So you can see we can create some really interesting compositions here. Right click on that level, go back to the mirror mode. We can do top to bottom, so it's just taking anything that's above this line here and it's going to mirror it down to the bottom there, like so. And again, if I bring that up, you can see what's happening. If I wanted to, I could bring another piece of clip art in. Let's take a look. Let's just shrink that down, and you can see with that at the bottom nothing's happening here, because we're currently in a mirror mode where we are mirroring from top to bottom. Now as that's on the bottom, nothing can happen. The moment we move it to the top, then we'll see it being mirrored to the bottom there. Okay, let's just right click and go to the mirror mode. We'll go to bottom to top this time. So anything that's on the bottom will be mirrored to the top here. So again, we can't see this because it's in the top. Bring that down to the bottom and we can see it's now being mirrored for us. And again, any overlaps will not be accounted for. And you can see we can create some really interesting shapes using the various mirror modes. And again, you'll notice that we have a line running through that combine mode, and that's telling us that we are currently in a mirror mode that's running from bottom to top, so it's along the horizontal there. So then we have 4 extra options where we can mirror by quadrant. So let's take a look at those. So we'll go to the top left quadrant to begin with. And so what that will do is it will take any components that are in this top left quadrant and it's going to mirror them to all of the other quadrants also. So let's just shrink that down. We could just look at rotating that, bring that over. I'm going to bring that over so it's touching the edge, and then bring this one over, and you can see every time I move the part we're getting instant results here in the 3D view, so I'm able to see the overall mirrored composition. And again, if I come over the actual quadrant, this area of our component is not going to be mirrored because it doesn't sit within the top left hand quadrant. Again, we could right click, go to mirror mode, let's do top right quadrant, and it's just going to take everything in this section here, so I can take that, move that over, and again you'll see that everything will be updated to account for the components that are in the top right hand quadrant being mirrored elsewhere. Right click here. Again, you'll also notice now that we're mirroring by quadrant, we have 2 lines running through that combine mode, and that's just again just to indicate to us which mirror mode we're currently using. See bottom left quadrant. So again, it's only picking up this quadrant here, and so if I rotate this, you can see the shapes that we can create. You can take this one and bring that down, and then rotate it, and you can see we're constantly getting really nice compositions here within our 3D view. So let's have a look at the final one, which is the bottom right quadrant. So that's this one over here. So bottom right is there. We can take that. We can just look at rotating that, and we could just shrink it a little, bring that over, and again we've got some really interesting shapes here in our 3D view. And so you can see that we can effortlessly create really interesting 3D compositions using the various mirror modes that we could apply to compositions or machine as a standalone piece. So to see this in action as part of a project, you can take a look at the coat of arms tutorial that's available from the tutorial browser. So the first thing that you'll notice is that we've reordered the modelling tools into a more logical fashion. So the first row of icons here represent all of the model creation tools. The second row of icons here represent model file import and exporting tools. And then the bottom two rows that we've got here represent the tools that we can use to edit our models. You'll notice also that we have two brand new icons in the model creation section, where we have the brand new turn and spin tool, which we'll look at shortly, and we also have an icon to create a zero plane. Now the ability to create a zero plane isn't new. In previous versions, to create a zero plane, we access this using the model drop down menu. For ease of use, we've introduced an icon as part of the model creation tools. So let's take a look at the brand new turn and spin tool. Before we go in there, I'm just going to switch on the visibility of the bottle layer, and then we can come over to the turn and spin tool, click on that and open up the turn and spin form. So this form allows us to create two types of shapes: turned shapes and spun shapes. Let's look at the turn feature to begin with. So the turn tool allows us to create rounded symmetrical shapes where we take one cross section and one cross section only, and we turn it around a line from its start point to its end point. So let's have a look at how this works. So to turn a shape, I need a cross section that represents the silhouette or half of a side of the shape that I'd like to create. So you can see here we have a vector that represents half of a bottle shape. And so if I select that cross section, I'm able to specify whether I want to turn or spin that shape. As I've got turned selected, it will rotate this vector cross section around a line from the start point to the end point. So the start point is here, the end point is at the bottom here, and it's going to rotate that to create the full shape. So let's just tile the windows and we'll see what happens when we turn or we rotate that shape. So let's press apply. Okay, and so you can see that we've got a full bottle there. Okay, so it's took that cross section and it's simply rotated it about a line running from the start to the end points to create this nice rounded bottle shape that you can see here. And the way that the software creates the height for the component within the turn option is purely based on the width of the vector. So whatever the widest part of the vector is, that's how high your component's going to be. And so this is a really simple tool to use if you're wanting to create symmetrical rounded shapes like the one we have here, where all we need is one cross section that we turn to create the shape. So let's just give that a name. We'll call that one bottle, press apply and close that. We can see it's been added to our component tree. Just going to switch this off for the time being, and now we're going to look at how we can spin shapes. So let's go to our layer manager, switch off the visibility of the bottle, switch on the visibility of the plate layer. We're going to go back into the turn and spin tool. And so to spin a shape, this allows us to take a single cross section and spin it around the cross section's left end point in order for us to create a circular shape with the profile of your cross section. So let's have a look at our example. So if I select that cross section here and we spin that around the left end point, it's going to spin this cross section about the left side of this vector, and it's going to spin it to create a circular shape that will have a profile that matches this cross section here. So let's just go ahead and press apply, and then we can see the full circular shape that it's created. And this full circle is based on the width of the vector, which is ultimately the radius of the circle that we plan to create. And then the height of the component is created from the height of the cross section. So very easily, using one cross section, we've created a rather interesting plate component. And so the ability to create these types of shapes isn't new, it just requires less vectors for us to create them. And for more information on the new turn and spin feature, you can watch the turn and spin guide that covers this tool using lots of different examples. And to see the turn tool being used as part of a two-sided project, you can watch the King chess piece video to see this in action. So here we're going to look at some of the enhancements that have been made to version 9 with regards to toolpaths. So we're currently in the 2D profile toolpath, and you'll notice a few changes here. So we've got the add tabs to toolpath is now in a section of its own, and that means that we've made room for a new tab at the bottom here, which is called Start At. So let's have a look at the brand new Start At tab. And so in the Start At tab, we are presented with 3 different options. Now the first 2 options, keep current start points and optimize start points, are not new, but they have been moved from the machine vectors section into this new Start At section, where we have a third brand new option to move start points to be closest to a selected point on the vector bounding box. And so this enables us to influence the start point in a profile toolpath by defining which part of the bounding box of the profiled vector it should start near. And this can be used to closer control the movement from one vector to another, and can help eliminate tool entry and witness marks in key areas. So let's have a look at that option. So if we just come down here, and then we'll select the vectors here, so it's just selecting the outer vectors, and in this instance, let's say I want the start point to be closest to the mid left side point of each one of those bounding boxes. I can simply go ahead and press calculate, and we can see it's just picking up the middle section there on each of those. Let's go back in, double click there, and we'll just come down to Start At. This time I'd like to choose the option to start in the mid top point, so I'm just going to click there and press Control and calculate, and you'll see we're starting at this point here. It's going to cut that out. It's going to move over to the top midpoint of the next shape and cut that out, come down, move to the top midpoint of that shape, and so on. So you can see we've just got greater control, being able to specify points that are closest to a selected point on the actual vector bounding box. So let's just calculate that. It's automatically going to open up the preview toolpath form. Now, as I mentioned at the start of the video, the toolpath drawing visibility is moved from the bottom of the toolpath preview form to a permanent position at the top here in the view toolbar. So if we go to the 2D view, we can see the actual drawing there, and if I just switch that off, you can see we can't see that anymore. Switch that back on so we can see the actual Toolpath 2D drawing, and then if I toggle this switch here, that will switch from a wireframe, which it currently is at the moment, to displaying the solid view here. Another enhancement that we've made to the toolpaths is that we've added the job setup sheet to the toolpath operations for easier access. So now when I want to create a setup sheet, I simply click on that, save the file, and then my job setup sheet has been created. A brand new feature that we've added into version 9 is the Array Copy toolpath. And this tool allows you to duplicate one or more toolpaths as a block copy, which is very useful if you're wanting to mass produce one item, allowing you to take a selection of toolpaths and array them in a grid fashion. So let's go to File, Open. We're going to open the Vectric widget file. Okay, so here we have one widget. Let's go over to the Toolpaths tab, and we're just going to preview all of the toolpaths that we've got for this widget. So you can see we've got profile cutout, we've got pocketing, we've got drill holes, we've got some V-carving for the crosshatch and V-carving for the actual Vectric widget text. And so this prototype has been approved for mass production. So let's have a look at how we can use the Array Copy toolpath to create all of the duplicate parts that you saw earlier. So let's just close out there. I'm just going to switch over to the Drawing tab. I'm going to go to our job dimensions and origin. I'm going to look at making this out of material that is 96 by 48 inches, so working with sheet material here. We could go ahead and just press OK there. Okay, so let's just tile our windows. We'll use the page down option, and we'll go back over to the Toolpaths tab. And so then you'd simply select all of the toolpaths that you want to copy. In this case, that's all of these. I'm going to use this option here. Okay, so you can see that there in the bottom left hand corner. And with all of the toolpaths visible, we simply come over to this new icon here, the Array Copy toolpath. I'll open up the Create Array Copy toolpath form. Okay, so we can see all of the toolpaths visible in our list here. So you can see the tools we're using. So we've got 3 toolpaths that use the end mill, and we have 2 toolpaths that use the 90-degree V-bit there. And then this middle section here pretty much resembles areas from the Array Copy tool within the Drawing tab. So you may be familiar with what some of these options mean. So here we specify our rows. So in this case I'm going to have 5 rows in Y, and then columns I plan to have 11 parts going along the X axis. Then we choose whether we want to offset that or put in a gap. In this case, we're just going to put in a small gap of 1.5 in X, 1.5 in Y. Then we move on to the bottom section here. We have the option to minimize tool changes, and so by default with this unchecked, the Array Copy toolpath will run all of the toolpaths for a single part and cut that out, and then it will move on to the next one and run all of the toolpaths for the next part in a linear grid fashion. And this means that as we have multiple tools being used for our one part, it will require a tool change for every part it starts cutting. So we're going to need a tool changer on our CNC or a compatible post-processor, which will allow a pause while we change our tool manually. So if you wanted to create each part one at a time, allowing us to remove the part for finishing while the machine continues with the next item in the grid, then we'd leave this option unchecked. Then you could give that a name, and then we could simply go ahead and press calculate. And so you can see it's created all of the copies in a linear grid fashion where we have 5 rows and we've got 11 columns, just as we specified in the Array Copy toolpath form. And you can see that we have only one set of toolpaths, and that is now within a tree. And so we have the Array Copy toolpath, that consists of 5 individual toolpaths. And if we undraw the visibility of the toolpaths here, you can see that we still only have the originating set of vectors for the part. So let's just switch on the visibility of the toolpaths there. I'm just going to maximize the 3D view, and we'll just reduce the speed here, and we'll just preview all the toolpaths. So you can see it's cutting everything out for the first part, including the V carving, and again it's working away in a grid fashion. We could speed that up if we wanted to, so you can see how that part is being arrayed along our sheet. And so, as I said, this is really useful if you're wanting to take each part off once it's been machined for a manual cleanup, while the machine will continue to run the next part in the array. Now, if we wanted to minimize the tool changes, where for instance in our example we wanted to run all of the toolpaths that uses end mills to begin with, followed by all of the toolpaths that use the V bit, then we can go back into the form and use the option to minimize the tool changes. So let's just close out of the preview there. I'm just going to double click on the array toolpath. I'm just going to switch on the visibility there. And we'd simply use this option here to minimize the tool changes, press calculate, and then we could just simply reset that preview, and then if we just slow the preview down, we can preview all the toolpaths, and you'll see that we're just cutting all the toolpaths that use the end mill to begin with, and it'll do all of the parts till it gets to the top. Once it's done that, I'll have a tool change and then run the V bit on all of those parts. We can also edit the individual vectors and individual toolpaths and then update the array copy toolpath to accommodate those changes. For example, if we close out here, we'll go into the 2D view, and I'm just going to zoom onto this selected area. Now say I wanted to change this text, so that's selected. Let's open up the drawing tab, go into the text, and I'm just going to change this to V9, press apply, close that, and I'm just going to take that and rotate that twice using the 9 key, go back over to the Toolpaths tab, and then all we'd simply do here is just recalculate all the toolpaths. Okay, so it's successfully recalculated that for us, and then if we just tile our windows, and then if we go into the preview, we can reset that preview, and then preview all of the toolpaths. And it will do that. If we maximize that and zoom in, we can see that all of those widgets now have V9 in place. And so there's lots of scope there for editing existing designs, and this tool will make it so much quicker and easier to create multiple identical parts where we simply array the toolpaths. And to learn more about this new feature, you can take a look at the Array Copy and Merging Toolpaths guide in the tutorial browser. As I mentioned at the start of this video, we now have the ability to create a double-sided project in the same session. And so this means that we no longer have to create 2 separate files to create a full 2-sided part, as it's all done in one sitting, where we have the ability to visualize the 2-sided part in both the 2D and the 3D view. A very powerful feature that we can take advantage of so that we can see exactly how the 2 sides compare, which ultimately minimizes any inaccuracies that we faced in terms of alignment and how the full 2-sided part looks in previous versions. So let's take a look at an example of a 2-sided project. This is a getting started guide to working with 2-sided projects in the software. There's a much more detailed version of this tutorial that is available from the Vectric support website that you can access by visiting support.vectric.com. Now the file that we're going to look at now to demonstrate a 2-sided project in the software is based on one of the free monthly project files called Cool Cubes. And the file that I'm going to work with is an edited file which you will have access to in the project folder. So we're going to look at creating a version of one of these boxes, and these boxes are designed in a way that we cut the decorative elements on one side of the material and a series of pockets on the other side, and these pockets will enable us to assemble and join them together to create the box. So let's go into the software to set up our part. So let's go and open an existing file. From the project folder, we're going to open CoolCubes_edit. So here we're looking at the overall design for one of the CoolCubes boxes, where we have a box with 4 sides and we have a top or a lid here. The bottom will be cut separately, that's just a simple square shape. We have vectors on the left and on the right here that represent the dowel hole locations for when I flip the part over, and then we've got text here just telling us what each panel represents. Now the file that we opened was originally saved from a single-sided session. Now as we are creating a two-sided part, I need to create a two-sided environment. So let's go over to the job setup form. So here we're going to select double-sided job type. The job size will remain the same here. Moving on to the Z0 position, here I'm going to set that off the material surface for the top side, and then we're going to zero off the same side for when I flip the part over. That ensures that the Z is always referenced from the same face of your material. XY datum position for both sides will be in the lower left hand corner. Then we need to specify the flip direction between the sides, and it doesn't matter which one you choose, you just need to remember how to replicate this virtual setup for when we physically flip the material over to cut the bottom side. In this case we're just going to flip that along the X axis. Then we can go ahead and press OK. So you'll notice now that I have icons at the top here. Now this icon represents the direction I chose to flip my material, and so being able to see this throughout my session will remind me which way I chose to flip the material. Then we have this button here which indicates which side I am currently viewing. We can see that the arrow is pointing to the top of the block, therefore I know that I'm working on the top side. To switch to the bottom side I can simply click on that icon and you'll notice that the arrow is now pointing to the bottom, telling me that we are now looking at the bottom side. You may also notice that my rules have changed colour, and this is just another indication to remind me that I am now on the bottom side. I also have an additional button over here on the right hand side which enables me to work in a multi-sided view, and this enables me to see vectors that I may have on the other side in the 2D view like I can see here. It also enables me to see 3D information in the 3D view, for example when I simulate my toolpaths, and we'll look at that later on. If I switch off the multi-sided view, I'm only able to see what is on the current side that I'm working with. At the moment, all of the vectors are currently on the top side, that's why I can't see anything here. And if I turn on multi-view, I can see the vectors on the other side as though I was looking through the material. Now these vectors that I can see on the other side are a light green. I can't select them or edit them on this side, I can only see them. And this is very useful, having the ability to see information that exists on the top side in terms of where I align new vectors for this bottom side. And not only that, but I can snap to geometry that exists on the other side. For example, I could draw a rectangle and snap to the rectangle, the square that exists on the top side, and I can do the same for other shapes also. And so you can see I'm able to easily draw or almost trace around items that exist on the other side. It's going to take both of those and we're just going to delete them. And so having the multi-view switched on is very useful for me to see all of the information in one session. So let's just switch back to the top side. Now I don't need to create any vectors in this example. I have all of the vectors that I need to create the box. I just need to organise them in terms of what side they're going to be cut on. So I'm just going to click and drag a box in the upper left direction, and anything that touches that selection box means that it will be selected. and you can see that I'm just holding down Shift to select the other vectors. So the vectors that I've got selected here, I want to move them over to the bottom side. To do that, I'm going to right click, use this option here, move to the other side. We can see that they are now on the other side, they're represented by that green colour, and if I switch to the bottom side, we can see that they have been positioned over to the bottom side there. And the really nice thing about this is that the software does all the hard work for us, where it will position the geometry in the appropriate positions relative to the opposite side. So you never really need to worry that your data is misaligned, as the software automatically positions and aligns the data for you based on your flip direction. And so using the multi-sided view, you can proof your data positions in the 2D view, and we can see that everything is correctly aligned there. So now I want to run through how I plan to cut the whole part. So let's switch to the top side, as we'll be cutting the vectors for the top side first. So in terms of machining, I plan to cut these vectors, and we're going to run pocket toolpaths on those. Once we've done those, we're going to take this vector and this vector over on the right here, where we're going to run a drill toolpath, and these holes represent our dowel holes. We're going to cut all the way through the material, and we're going to cut into the spoil board, where we'll then take our material off as we've finished with the top side, and then we're going to put the dowels into the spoil board, and then when we flip our material over, we're going to align it back in X and Y into the position, secure the part in place, where we'll then go and run the toolpaths for the bottom side. I'll look at machining all of the decorative elements, followed by profile cutouts to cut all of these panels out. So let's go and run these toolpaths. We're cutting the top side first, so let's switch to the top side, and then we'll switch over to the Toolpaths tab on the right hand side. So the first thing that we want to do is just check over our material setup. So we'll use the set icon here. Material thickness 1/2 inch, XY is in the lower left. Z0 for the top side is the material surface. You'll remember we did that at the start of this job in the job setup form. Check over the rapid Z gaps above the material. Home, start, position and Z gap above the material are all safe and appropriate, and then we could go ahead and press OK. So I'm going to select all of the horizontal rectangles here by holding down Shift. I'm going to go and run a pocket toolpath on those. Start depth in this case is going to be at 0, the material surface. Cut depth, we're going to cut down 1/8 of an inch, so we're just going to type in 0.125 in there. The tool that we're going to use, we are using a 1/4 inch end mill. If I use the select option here, you can see I can access all of the tools or create new tools and edit the tools within my tool database. So here's the 1/4 inch end mill. I could check over the settings there and go ahead and press OK. And then coming down the form, we're going to raster this. So we're going to clear the pocket in a raster pattern where the raster angle is going to be 0. So it's going to raster that along the x-axis. And then we're just going to go and give that a name. So we'll just call that one pocket 1 and then press calculate. And you'll see it's created that there. And then I could go ahead and preview that toolpath. And so you can see how the part looks. So what I see here is exactly what we're going to get on our CNC when we come to run that toolpath. So let's just put that in Z. We're just going to close this preview down. I'm going to go back over to the 2D view. This time I'm going to select all of the vectors that represent the vertical pockets. So with those selected, let's go into the pocket toolpath. Start depth again is going to be at 0, the material surface. This time we're going to cut a little bit deeper, so I'm going to make that 1/4 of an inch for the cut depth. I'm going to use the 1/4 inch end mill. I can use the edit option here just to glance over the settings. If I wanted to edit anything I could, and it would change it for this particular toolpath alone. We're going to clear the pocket in a raster pattern. This time we're going to raster that at 90 degrees so it's parallel to the y-axis. Give that a name. We'll just go with pocket 2 here, and then could go ahead and press calculate. We could preview that, and again we can see how that part looks. Okay, so I like what we've got there. put that in C, and then we'll just close out of the preview toolpath form. So let's go back to the 2D view. Now we're going to look at creating our dowel holes. I'm going to take this vector here and shift and select this vector here. Now these dowel holes are symmetrical, so that when we flip the part over, we will have correct alignment in X and Y for both sides of our material. So with those vectors selected, we're going to come in and use the drilling toolpath. So here we're going to have a start depth of 0, and we're going to cut all the way through the material, which we know is 1/2 inch, and we're going to go a little bit further into the spoil board so that we can insert the dowels into the spoil board for our alignment when we come to flip our material block over. So we'll leave that at 1 inch. Tool we're going to use is a 1/4 inch drill. You can see the settings there. Happy with those, so I could go ahead and press OK. I could give that a name, so I'm just going to call this one drill dowels, and then we could go and calculate that. Software is going to warn me that we are cutting all the way through the material past that material thickness, which I'm okay. I intend to do that, so I'm going to go and press OK there, and then we could preview that toolpath, and we can see the dowel holes have been positioned in a 3D view there. And so that's all of the toolpaths for the top side. So at this point, what we'd do in terms of the physical setup is we'd take this material block off of our machine bed, and we'd insert the dowels into the holes that have been drilled into the spoil board, and then we'd take our material and we'd flip that over, and then we'd position that and align it to the dowel holes where we'd secure that in place. And because we've aligned it to the dowel holes, we know that our XY coordinates are going to be aligned with each other. And then we'd look at running the toolpaths for the bottom side. So let's just close out of the preview toolpaths form, and we're going to go and switch over to the bottom side. So we've flipped our material over. Let's go into the 2D view. Now over at the top here in the Toolpaths tab, we're displayed our material setup summary, which is very useful for me to glance over the settings that we've got without me having to go into the setup form. So I can see XY0 position is in the lower left hand corner, material thickness is 1/2 inch, we've got our Z0 for the bottom side on the machine bed. So you'll remember when we set up the job, we did it so that we're always referencing Z0 from the same face. So once I'm content with that, we can go and run our set of toolpaths. So I'm going to select all of the vectors that represent the decorative holes on the front side of our box. With those selected, we're going to use the profile toolpath. Start depth is going to be at 0. Cut depth, we're going to cut down 1/8 inch. I'm going to use the select option here, and I'd like to use a 1/4 inch ball nose to cut this out. We'll go ahead and press OK there. I need to choose which way I machine the vectors. In this case, I'd like to machine on the inside of those vectors, and then coming down the form, I can give that a name. We'll just call this one Profile Decoration, and then we could go and press Calculate. It'll calculate that for me, and then I could go and preview that, and we can see what our part looks like. So you can see we've got these nice decorative holes there on the face of our box. So let's just put that in Z, and we're just going to close out there and go back into the 2D view. And now we're going to look at creating profile passes to cut all of these panels out. So I'm just going to box select all of those into the profile toolpath form. We're going to cut all the way through the material. One way of doing this is I could type in Z and equals, and then the software will automatically input the material thickness that I set our parts. So it's put in that 1/2 inch in there for me. Tool we're going to use is a 1/4 inch end mill, so I'm going to select that, press OK. This time we're going to machine on the outside of those vectors. If we come further down the form, I have the option to add tabs to my toolpath, and so this will hold my part in place if I didn't have a vacuum hold down system. And I could check that, and it's going to remember the tabs that I've previously inserted here. I can edit the tabs if I didn't like where they were positioned, so I could click on one to delete it, I could click to reinsert it, I could click to move them, or I could just go in and enter a new constant value in here and it will automatically put those tabs in place for me. So let's close that. I'm happy with the positioning of those tabs, and then I could just give that a name and we'll call that one Profile Cutout, and then simply press Calculate, and then we could go ahead and preview that toolpath. And so I can see how my part is actually going to look when we come to cut that out on our CNC. And because we're in a multi-sided environment, I can also view the toolpaths that we previously cut on the bottom side. And so it's very important here that your part looks correct at this stage, as the toolpath preview shows you an accurate representation of what we'd see on our CNC machine if we was to go ahead and run these toolpaths. So if something doesn't look as you wanted it to here at this stage, you can go back and make edits to the toolpaths and then recalculate them until you are satisfied with the results that you see here in the toolpath preview. And that's what makes the toolpath preview with the multi-sided view switched on such a powerful tool when working with two-sided parts. So at this stage, now that we like what we see in our toolpath preview, we could safely say that we could go and save out our toolpaths. So to do that, we'd simply close the preview toolpath form down, and then we could go over to Save Toolpaths. So I could simply select one of the toolpaths here. If I wanted to, I could choose this option to add side to the toolpath name. Then you'd go ahead and select the post processor from the list, and this will format the data for your particular machine. So you need to choose one that is suitable for your machine. So then we'd go ahead and save the toolpath, and you'll notice it's already put the bottom at the start of the profile name, as we had the add side to toolpath name option checked here. So it just makes it easier for me to know which toolpath I'm selecting when I come to run the toolpath. So all the bottom toolpaths will have bottom in front of the name, and all the top toolpaths will have top in front of the name with this option checked. And so I'd simply save that out. I could select another one to save that. You'll see it's called Bottom Profile Cutout. I could save that one, and then I could come over, switch to the top side, where again I could simply save these toolpaths out, and again it will come up with the name top in there. And so you'd save those out for the other toolpaths that you have in the list there. And so the last thing to do here would be to save the file, so you have a copy of that where you can make edits to it at a later date. So go to File, Save As, and in the project folder I'm going to call that one Two-Sided Machining, Getting Started, and then I can press Save, and that will save that for us. As I said earlier, there is a longer version of this tutorial that is available on the Vectric support site that covers this example in much more detail. Now, not only is there a more detailed version of this tutorial, but there are two other tutorials available that run through the process of importing a 3D model for two-sided machining and how to create your own 3D model to create a two-sided part, and these can be found on the support site. Thank you for watching. So that completes this What's New video. For more information on upgrading to version 9, please visit the Vectric website. Thank you for watching.